Okay. Welcome back. I hope you have enjoyed your coffee break and that you are enjoying this symposium as much as I'm doing. I would like to first thank our sponsors, as without them this event could not have been possible. And now I would like to introduce our next flash talk, Market Uptake and R&I Challenges for Zero Emission Aviation. At EUROCAE, together with key EU R&D programs as SESAR joint undertaking, we have built extensive experience in bridging research and market uptake with the publication of standards that answer the need to harmonize new technologies, mainly in the fields of ATM and IAS. In the context of the current environmental concerns, new sustainable technologies are being developed in line of net zero aviation goal for 2050. Programs as Clean Aviation Joint Undertaking are working with the industry in research projects supporting the transition to sustainable aviation. I would like to give the floor to Maria Calvo, Head of Unit Project Management at Clean Aviation Joint Undertaking, which will provide an overview of their work and main challenges in the development, certification, and standardization to achieve zero aviation. Please, Maria, the floor is yours.
So thank you to the EUROCAE community, to Esther, Anna, to invite me today to join you in this community. My name is Maria Calvo, Head of Unit for Project Management in the Clean Aviation Joint Undertaking. I had the opportunity exchanging with you in the last night and today, finding a few of our contributors to the projects with the audience, but others who are not so familiar what we are doing in the joint undertaking for clean aviation. So I wish this will give a comprehensive overview of what are our challenges and how we are contributing to a net zero aviation. So I would like to start with this picture that many of you probably have seen before, but actually is the origin of our mandate. As a joint undertaking, we are a public and private partnership of the European Commission and the main aeronautic stakeholders in Europe, industries, research centers, SMEs, and also universities. With all them, we create a strategic research and innovation agenda, so we focus towards the net zero society by 2050, mentioned by Esther in the introduction. So why we are contributing to that? As you can see in the picture, transport is one of the elements that need to be tackled in this challenge to achieve net zero emission. And aviation is a part of it. It's around 14% of it. And it's our mandate to address this. And how? We are addressing it in clean aviation joint undertaking through technologies development. But I want to share first this graphic with you, because to reach net zero emission, not only technology development is sufficient. We need to have technology development are also new fuels. New fuels being sustainable aviation fuel, but also hydrogen. Altogether, the different elements can bring this target to be able to achieve this target of net zero aviation. And also in this chart, I wanted to give you the overview about how the different aircraft segments are contributing to the global CO2 impact. Our program is based on impact. We are trying to assess what is the reduction from different aircraft concept and technologies, so we can provide by 2035 entry into service technologies. So we are really looking to impact. And you see in the graphic that actually there are the regional and short-medium range aircraft segments are more than half of the contributors to the CO2. So our program is focusing first in this element to target more than half of the emissions and to be an intermediate step for further scale up for the long-range application. So where would we sit in the European Green Deal? Because the European Green Deal is the origin from our mandate. So we sit in the part of research and innovation. Research and innovation focus, as I mentioned, for aircraft technologies and aircraft concept, able to bring this impact, this reduction on emissions. Mainly CO2, but not only. For aviation, it's also important to tackle NOx and particles, contrails, still without a consensus on how to balance the different elements, but we will monitor, and we are also putting some exploration of the different validation of these technologies to be able to measure the global impact. But in order to achieve the net zero, as I said, is not only about technologies, it's more. So what we are doing, even if it's not part of our mandate, we are also a member of the Alliance for Zero Emission Aviation at SIA. That's where I met Esther from EUROCAE, and we have the opportunity to exchange the other elements that are needed in the ecosystem to make this net zero happen. So what are the concepts of operation? What are the changes at airport level that are needed? The ground equipment was mentioned this morning in the flash talk as well. The fuel availability and the fuel distribution. Not only sustainable aviation fuel, but also hydrogen, how to get there. Also in terms of training of the crew, training of maintenance. All these elements are discussing at SEA. It's not part of our mandate, but it's also a strong will from our side to create these bridges and to create these synergies so we have the same vision and the same ambition. And then a little more on detail on the programs. So we have two phases in clean aviation. Phase one, that is more about development and maturation of technologies. Technologies option, trade-off studies, what are the different aircraft configuration optimum solutions. And then in phase two, that's actually, we will start with a call already next year, 2025. We will further maturate these technologies up to TRL 6. What does it mean? We are going to flight test some of these technologies and also full-scale ground testing. The aim, as I mentioned before, is to be able to achieve and enter into service technologies for 2035. The volume of the program is about 4 billion euros. 1.7 is provided by the European funding from the Commission, while our members are committed to contribute with 1.5 cost on top of that, giving a global figure of 4 billions, plus the UK funding that is currently under discussions after UK was included as associated country to Horizon Europe. We are not starting from scratch. We are capitalizing from Clean Sky 2 progress. That was a very successful program from 10 years, finalizing this year, and I will recommend you to have a look to the achievement report in the second part of the year to see the results. And then I will focus more on the technologies and innovation. So we are putting our projects around three main thrusts. One is about ultra-efficient solution for short-medium range aircraft. Another is about hybrid electric solution for the regional aircraft segment. And another thrust is about hydrogen-powered aircraft solution, the targets I mentioned before. And actually, also we are targeting a fleet replacement of 75%. This is a summary of the different projects that are in clean aviation. I'm not going to go in the detail of that because this is a flash talk, but just to give you the overview that we have mainly propulsion project with different engine configuration, propulsion configuration, ducted, unducted, direct hydrogen burn, fuel cell solutions, combined with the more conventional activities. And you see EASA on board, and I will elaborate a little more after that on that. Hybrid and regional concept, this similar one, propulsion mainly based on hybrid electric solution, including also fuel cell. and also batteries. And here we have also the transversal programs, EASA. EASA is contributing with a service contract to all of our projects, working together with researchers. That is a quite of innovative approach. I wanted to share with you the main challenge for hydrogen-powered aircraft that I thought it was good to share with this community. So you see there mainly the liquid hydrogen tanks, where we have to achieve an adequate, a high level of power density, and that in a situation that is in a low weight and low volume solution to be fit in the aircraft. Then we have fuel cell. We have several projects around fuel cell for different applications. Since more fuel cell integrated in part of the nacelle, 2 fuel cells on the fuselage of the aircraft, going up to megawatt level. As well, we have the propulsion solution, as I mentioned, increasing the efficiency of the propulsion system and including the possibility of also dual fuel with hydrogen or jet A kerosene. And last but not least, in hydrogen, also we need to have into account the fuselage integration topic when the tank is on the fuselage. How we are accelerating the certification aspects within the projects, because certification is key for clean aviation and is a novelty how we are dealing with that in research. Because of the entry into the service 2035, we identified EASA needs to be also a contributor, a key player in our project, discussing with the researchers about what are the gaps on the current regulation, what needs to be tackled, and that this is done through comprehensive and concrete examples and concrete technology development. As I mentioned, Clean Sky 2, we have some examples there of elements that actually were flight tested. So EASA was involved into giving the permit to flight, but this is to extend this certification awareness, not only for the industry or the OEMs, but for the full stakeholders from university, SMEs, research centers, so everyone understands the challenge of certifying the technologies that for aviation is a long-term discussions. Out of clean aviation, but also relevant, are the discussions I mentioned before about the fuel availability, ATM, infrastructure, and the emission models, like the NOx and contrails and these type of things. I wanted to share with you a specific project that we have in clean aviation that is dealing with certification proof of concept. It's not the only project that is interacting with EASA, as I said, because EASA is involved in all the projects, but this one in particular is called Concerto. I invite you to go to the website because they have just published a newsletter with the latest achievements from last year. This project is focusing in 2 main areas. The first main area is the digital framework. So they are also very well connected with the EASA, State Advisory Board, working group for the digital certification. So they are creating through a specific application this link about what will be needed in terms of digital means for means of compliance, follow-up of requirements, and new ways of validating and showing compliance. But also, it's developing proof of concept aligned of the 3 thrusts I mentioned before for the ultra-efficient aircraft, the hybrid electric, and also the hydrogen technology. In terms of ultra-efficient aircraft, we are going beyond the current requirements, exploring how high aspect ratio wing and additional flutter control and simulation could be introduced as new means of compliance, and how this acceptable means of compliance could be introduced in the regulations. In terms of hydrogen, as you can imagine, high voltage DC distribution, and the propulsion regulatory framework that could be evolution of spatial condition E19, could be an evolution of C, S25, combination with CSE. So this is type of elements that are being discussed. What is the best regulatory framework for this type of aircraft concept? And finally, hydrogen is mainly based on the fire requirements, flame requirements, and also the tank integration, and to be able to include new means of compliance for the structural tank. So in the end, Concerto is a certification enabler part of clean aviation, where EASA is involved in all the thrust contributing to our program. And last two slides that I want to share with you. I'm conscious of the time. So we are creating, we have already created as part of Concerto a new way of monitoring the progress of this certification aspect, these certification discussions. As you may be aware, as part of the research, we have the TRL, the technology readiness level. So now we have identified the need to have a certification readiness level. You can have more details on the newsletter for Concerto, but I will share with you in the next slide. In order to be able, where we are in terms of discussing with the authorities, what is needed in order to maturate the technology up to an entry into service. So we are in the phase of maturation of technologies, as you see there. First, you have to identify the concept, how we applied research and innovation activities, and which type of validation we are doing, including ground and flight testing. And then, out of the research, start the product development. So this discussion with EASA is not linked to any product development or any product application as per EASA current roadmap. It's an earlier discussion in order to shorten this product application interaction and defining adequate means of compliance and adequate regulatory basis. This is the scale that you can see more in detail in the newsletter from Concerto, and it's really a new paradigm and mindset in research and innovation that has been co-created with EASA and the main industrial players within aviation that are all of our members from OEMs, but also have other research centers and universities contributed. And it's actually an standardized scale that are used for setting the goals and also to monitor that EASA is also considering to include as part of their guidance materials. So really a mindset change for everyone to discuss openly what are the gaps analysis, the challenge of the technologies, and to anticipate and mitigate risk, and to select based on that the different and the best options that could be integrated in a future aircraft and a new generation of aircraft. So with this, I would like to thank you all. So this is our goals is to innovate, to accelerate, and collaborate. As you can see, collaboration is key as part of our program, and we want, apart from our program, to create synergies, to create the bridges, like here with EUROCAE. I wouldn't be surprised that some of the working group in the next years from EUROCAE are deriving from discussions taking place in the projects in clean aviation. So thank you very much. Do you have time for some questions or not? No?
Thank you very much. Asking Frédéric Trincal to come down with the other speakers. Yes, thanks. Yes, thanks. Please come. So, welcome to panel 6, Exploring the Future's Technology Frontier in Aviation. So I'm stepping in today for my colleague Chuck, who organized this panel. In this session, we'll delve into critical factors related to R&D and technology deployment. Our discussion will highlight the challenges and opportunities in implementing cutting-edge technologies. We'll also consider the impact of human factor on safety-critical application in aviation. Stay tuned as we explore prediction and trends from blockchain to quantum computing, Internet of Things, and virtual and augmented reality, all with a focus on aeronautical safety. Giving the floor to Peter Hodden.
Thank you. Thank you. So, pretty much that describes everything we've talked about over the last 2 days and beyond, all in a very short session. So clearly we've chosen to take a look at different aspects of this, but you'll see some themes get picked up along the way as we move through it that we've discussed earlier on in the symposium, which is a good thing. It's showing that we're actually having the conversations and the right conversations. So if I can welcome my panelists, first of all, to the stage, and then I will begin, and we'll hand over to the panelists as we go. So you see the names on the screen there. I'll come to the panelists in a moment, but I'll just begin. So the introduction, as I said, showed a very wide range of topic subjects, and one of them was crucial factors for starting new R&D and deployment. And I thought, well, I'm probably the best placed person to talk about that, coming from the SESAR 3 joint undertaking. We coordinate and concentrate research and development in ATM. And we've just heard from similar JU, Clean Aviation, and how they're working as well. But if I summarize just generally, success in R&D. So, first of all, are we evolving something? Are we creating a revolution? How do you know? Or is it just best to allow for anything to happen? So we need to establish early what we expect from this. What would we like to see? Not only what we'd like to see, but how can we measure them? How will we know? So we've got to allow the creative freedom, but also introduce this structured scientific approach. And it's coming on to something that was said earlier by Carol from RTCA in our council meeting, which is, I get asked a lot, I have to accelerate. So I ask the question, what does accelerate mean? So we get told the same thing. You've got to accelerate your R&D. So does that mean I do something, cut something out? But we've still got the same safety regime. We've still got the same need to measure our progress, know where we've got to, know we're delivering benefits. So you can't cut something out, but we can work together in a more seamless, transparent, and harmonious way. And we can start to anticipate what the regulatory constraints may be. So I'm already into deployment and I'm still in R&D. But it's best to start thinking about this early. We heard earlier engagement of EASA, so we engage with EASA. But we've also got the European Commission and EUROCAE on board within our joint undertaking. And we're doing R&D. But it's an important aspect of how we might accelerate. So it's not doing less, it's doing what we do a bit better. Okay, so that's my key message for the acceleration. So we need to consider a range of realistic operational conditions when we start to validate our R&D. It's not just sitting in a lab in isolation, it needs to start to represent real operational conditions. You need to look at things like failure, and more importantly, and it's often even more difficult, recovery. And this is R&D. Don't be afraid to stop. Change direction, because you will know more as you go. So stopping and changing direction is not a failure. Trying to deploy something that won't work certainly is. Okay, so another prime principle. Establish a wide-ranging vision. You know, we know in ATM we have the European ATM Master Plan, and we're going through an update of that at the moment. Plan, get the buy-in, identify the stakeholders who support and will help you drive forward that change. And think from local to global. Aviation is not a local business, it's a global business, so it's got to address the global aspects too. And we're still in R&D. You start getting towards deployment and you go, actually the main factor then is we did good R&D. Seems obvious, but you know, how many times have we asked ourselves the question, did we do good enough R&D? And have we demonstrated it? This is a way of helping transition towards operation. We need to be clear about the change we're trying to make, how we'll measure success, what innovation really is, which is changing the market in a positive way. Identify your influential leader, somebody who's going to help you drive this through. How many ideas and great things have fallen by the wayside, only to be picked up many, many years later because they were never really sponsored, supported. So try and find that leader. Communicate the benefits, really showcase. You know, no matter how much you do in the communications, you get told, oh, you didn't tell everybody, you didn't tell us, you didn't. It's always criticised for not communicating enough, so do as much as you can. And when you come to transitioning to the market, you need to try and accelerate that take-up, create the right market conditions. So think about how you might get to the market. So that was my contribution for something to think about when you go back and say, well, we're doing R&D. Just think about some of those key messages and learnings and things that I've learned along the way and I think would be valuable for others. They don't get lost and reinvented. So the other question was technological frontier. And as I said, we heard lots about this during the week. We had new air vehicles, operations, safety, security, a new culture coming in. Environmental responsibility, do no harm. Airline operations, trajectory, mission and fleet optimization, physical infrastructure, airports, vertiports, and something I don't think we spoke about, but spaceports. It's another one. We've got air navigation services, air traffic and navigation management, service optimization, so delivering the best service, the service that's needed. Supporting digital infrastructure, CNS, information exchange, flight planning. And I know you've heard all about this from different angles all the way. I'm just recalling now the sort of things we talked about the last 2 days. And we talked about society, legislation and regulation, global interoperability, use of standards, building in for uncertainty, the role of the human, more automated in air transport, and something which we kind of got prompted at the front is our technological baseline, I'm coming back to this headline, unsuitable to meet our future challenges. And that's something that I want to discuss with the panels. The panel is, you know, that key question, is what we've got unsuitable for what we've just described today, or are we on the right track? And we're going to look at, with Frederick Collins, the air vehicle and onboard technology innovation, with Eduardo from CANSO, the operational innovations, and from Pascal of Thales, ground system and technology innovation, and from Alfred from NLR, the safety perspective in this changing world. So next step is to invite each of my speakers to address you with their perspective on that. Are we ready? Have we got the right things in place to move forward? So first of all, I invite Frederick to come and tell us about the airborne air vehicle onboard technology. Thank you.
So hello everyone. So actually, I've been into this industry for about 23 years now. And to be honest with you, I have never seen so much research and technologies developments. I mean, this is really unbelievable. I mean, the number of projects we have and the number of new technologies that are coming around. So I think we are really at the start of a big, big change around, I mean, the aviation industry. So as part of future aviation, what we are saying is that it will be data hungry. That's a given. I mean, so just to give you some ideas, I mean, if you compare to an Airbus A350, which is right now really, let's say, the most complex aircraft that we are flying today for the civil aviation, I mean, right now we are planning that there will be about 100 times more data inside the aircraft. So meaning that everything will be data-driven. So as part of my job, because I am a connected guy, so my job is really to connect aircraft, I mean, we are seeing many, many different factors that are driving, I mean, such a need for data. Number one, and just to articulate with the presentation right before, I mean, number one will be aviation sustainability. I mean, to be able to do that, we need to be able to optimize the airspace. That's really a given. And for that, we need to enable things like TBO, so trajectory-based operations, in particular with FFI's Release 2. So, and that one will really shift, I mean, the current operation, which are really human to human, to more a machine to machine operation. And at the end of the day, I mean, this one will enable really the collaborative decision making that we talked about also around the UAM presentation that we had before. So all of that, I mean, will participate to reduce overall our emissions. So we are seeing also that single pilot operation will be also driving a lot of usage of machine learning inside the aircraft. So in particular, like vision-based landing solutions. So it means that we need to collect tons of data to be able to also, at the end, be able to certify and make sure that those systems are safe to operate. Because as we discussed this morning, I mean, it's one thing to put AI, ML as part of an aircraft, is another thing to certify and be able to collect all the proper data, to be able to perform the right training of the algorithm is very important, but also be able to monitor all this information. Also, I will mention about the fact that SPO will drive the need also for increased situation awareness. So for example, if we need to have a ground assistant, we need the ground assistant to be able to know exactly what is happening inside the aircraft. So for example, you need to bring to the ground weather information. So everything that could be information in the cockpit, so all of that will drive a lot of volume of data. So that's going to be quite significant. Afterwards, of course, I mean, we have the increase in the number of airspace users, like, for example, UAV. I mean, right now, I mean, we're having quite limited number of aircraft flying. So, of course, I mean, that will increase with, I mean, those many various UAV that will come into the play. So, finally, I will also mention about the fact that we have maintenance also to take into account, because it's something to operate, but also maintaining is also very important. So, for that today, we are already collecting a lot of data. So we talk about ACMS data, so aircraft condition monitoring data, to be able to perform some prognostic, but we are just at the start. So for example, today, if you take an A320, today we are taking information from what we name the, let's say, the ACMS computer, so the FDIMU, and also from the engines, but tons of data are not taken into account, in particular from the back. I mean, talking about the cabin, the toilets, don't laugh, but that's part of it. Where we need also to make sure that in the end, I mean, to be able to operate an aircraft, we need to get all of that to be operational, and we need to make sure that we're able to predict when that happens. So what it means is that at the end, we need to put sensor everywhere. So that means IoT, so Internet of Things, all over the place. And for that, I mean, we're having some specific projects to develop, I mean, all this infrastructure, and that will for sure be part of the next generation of aircraft. Nevertheless, I mean, we are facing some headwinds. So in particular around the communication infrastructure. So today, I mean, you know that we're having some VHF congestion issue. So I mean, it's really, really a problem. For example, ACMS, I mean, the ACMS on engines is taking a lot of the volume of data. So we have started to look at solutions, of course, like a CARS over IP, but today, I mean, the deployment is not sufficient. So this is why we are now looking more at hyper-connected ATM. So basically, hyper-connected ATM, I'm sure many of you are familiar with the concept. So overall, it means that we're going to try to put the safety traffic on non-safety links, given that we still have the safety links as a backup. I mean, that's really the big condition to be able to do that. So that means also that we need to better use also the comments. For example, what's the point to use the VHF if you know that you are already at the limit in the distance with the ground system? So maybe it's better that you switch to something else before, I mean, you are breaking the connection. So we are looking at all of that. Of course, there is also some new communication means that are coming, like, for example, non-terrestrial 5G and 6G. So, I mean, we are seeing a lot of interest around that because that will give really a global coverage, something also agnostic, because the problem of the satellite communication today is that you need to have the satellite that is coming with the terminal, meaning that if you want to connect to another type of satellites, you need to swap your equipment, so which is usually impossible, otherwise the costs are gigantic for the airlines. So the idea of the 5G is really that, like you have your phone, I mean, if I want to switch from, I don't know, Verizon to, I don't know, T-Mobile, I can do it. I don't have to buy a new cell phone. And that's really overall the idea, and that will give us some opportunities, let's say, to get more data and more easily. I will also talk about something that is really a big problem for us, which is about the cybersecurity. So right now, I mean, as you know, air ground communication is really open. So we have zero security. That's very unfortunate. And I mean, given, I mean, the complex world, so the geopolitical situation that we are facing those days, in particular with the various conflicts on this continent, I mean, this is something we cannot continue. So moving to secured communication with AT and IPS, that's something we need to do. Because otherwise, I mean, this is not really something we can continue to do. So overall, in terms of security, what we are looking at is really to go to a zero trust framework, meaning that at the end, we make sure that we have security everywhere. So meaning that we trust nothing, nobody, so that, I mean, we create like an onions where you get multiple layers of securities. So that's where we are trying to go, meaning that we want to make sure that the future of aviation is also something secure and not something that is open. Like today we are really more into an ideal world, but that world is ended now. I mean, we need to make sure that we have the proper security. So another threat also that we have, this is the quantum computing. Because, I mean, this is emerging. I mean, those technologies are coming in the next few years. I mean, we should get some quantum computers that will be available. And the problem is that all the cryptography that we use today, I mean, will be breakable, I mean, by those computers. Nevertheless, and I think I will finish on that, I mean, this is also an opportunity because quantum computing is also something we can use, for example, to solve the complexity of the air traffic management. Because overall, I mean, this is a way to be able to calculate, I mean, all the conflicts and be able to perform the entire traffic deconfliction and also optimization, for example, making sure that everybody entering into the TMA, I mean, will have a continuous descent. I mean, so we need to look at what are the challenges and also what are the opportunities. So thank you. I hope I'm not taking too much time.
Thank you, Frederick. So that's the kind of airborne perspective, and I'll just remind you before we move on that the Slido is available as well. So when we get time at the end for hopefully some questions, then I'll go to the Slido. So please use that. So next, I'd like to invite Eduardo Garcia from CANSO to talk to us about the operations side, ANSP's operations, your perspective on the technological frontier.
Okay, thank you so much, and thank you, EUROCAE, for inviting me to be here with you and enjoy this spectacular symposium. So, okay, I have prepared just a few slides. I hope they are. That's Pascal. So, that's me. Okay. So, okay, I would like to share with you just some thoughts. It's more food for thought. I'm not presenting to you any solution, so don't expect that. But just some views from the CANSO side about the future, how our industry will evolve all over the years. And let's start by stressing some of the things that many of the speakers have been saying during the last 2 days, why we need to evolve, why we need to change, and why we are all saying that we are living a very interesting time of our industry. Yes, first slide is about the need to change. And I think it has been already said. Christine Berg was mentioning 2019, capacity was the big issue. The traffic was growing, delays were again up, and it was clear that there was a strong need for our industry to improve capacity. And we know when we think about the future after COVID, we see again traffic is growing strong again in many regions in Asia. And that is a huge challenge. But not only that, of course, we have been discussing a lot about sustainability is a key topic, a key priority. And security, and again, a very interesting panel about security that is impacting our industry. These are all very, strong forces that they are making us, they're pushing us to change. But when we were discussing with all our colleagues about the main reason to change is all these new entrants that again it was discussed in the panel before. And I'm not only talking about the drones, the eVTOLs, but the suborbital flights and vehicles with very different performances than the ones we have today. And we know the current system is not designed to address all these needs. So we are not a technology-driven industry. We look at technology, how they can help us to address all these needs. And that's why this is a very interesting time, because for many decades, safety was our main priority, and it's still, of course, nothing has changed about that. But we have more priorities now. And we need to address all these new needs, that they are very strong needs, and we need to understand how technology can help us. So let's start in CANSO as an association, civil air navigation service organization. What we normally do is to get together all our experts, similar way like in EUROCAE, and we identified some emerging technologies from artificial intelligence to blockchains, and we published some white papers. If you have not seen them, I recommend you to have it a look, trying to identify best practices, what the industry was doing, what were the future trends. It was very important for us to understand how these technologies could be used to improve air traffic management. But it was not enough. It was clear that we needed to have our own vision for the future on air traffic management, because for the last years, in ATM in particular, we have done incremental steps. We are all the time improving, but in small steps. When we think about the next 20 years, it is clear that fundamental transformations will need to happen. And for that, we decided to develop our own vision. We established a think tank because we thought it's not only for the CANSO members to work on this vision. We need to work with all these new companies, the eVTOL, the artificial intelligence startups. So that's why we invited all these companies to get together and work with us on this vision for the future. We created a think tank. It's CATS Global Council, Complete Air Traffic System Global Council. And we got together, SESAR with NASA, with NATO, and many other organizations. And we try to connect everything. It has been said many times, collaboration is key. And to understand the fundamental transformations that they need to happen in the next 20 years. And it's many of the things that has been said in the last 2 days again. Information exchange is critical. The connected aircraft, for example, that was mentioned yesterday. Moving into more service-oriented architectures that will facilitate a lot of innovation, virtualization, so a lot of activities that EUROCAE is already focusing on. But other transformations related to new flight rules and moving it, something as simple as moving to, well, not so simple, but moving to true north, from magnetic north to true north is something that already ICAO is discussing. We need a common or adaptive common altitude reference system. If we want to really integrate all these new vehicles, that is a must. And that, of course, will take us to new possibilities, to trajectory-based operations, higher levels of operations. Well, more in-time safety performance system, in-time, in general, performance management of our industry. So that's what we have been discussing with all these companies, more than 80 organizations. We are working on a document and concept of operations, trying to understand the impact of all these transformations in our industry. Okay. And again, it's good to see that most of these transformations have already been discussed in the last 2 days. Of course, under each transformation is a lot. When we discuss about higher levels of automation, the role of the human, how it evolves, we all understand is it's a complex topic, and about, again, the automation of the vehicle. And not forgetting disruption management, how we can improve the way we can have a graceful degradation of our systems, because we cannot just automate everything, and when everything, something is not working well, just say the human, now you take control. We know that doesn't work. So again, this is something, other activities we are right now working on. And let's not forget that at the same time that we are trying to understand all these fundamental transformations, and well, many of them mean a lot of work for ICAO because standardization is key. Let's not forget, of course, about advanced air mobility, all these new vehicles. Here, we recognize all the excellent work that is being done to accommodate the needs of all these vehicles in the short term, but we were concerned that all these efforts, sometimes too much focus on segregation or not changing really the current system that we have, were not enough. In the case, imagine that some of these meetings, they're very successful. We believe we need to be prepared to scale up and to address the needs of these businesses in a sustainable way. So that's why in this aspect, we have been working very closely with ICAO, not only to develop guidance material, but to work on a vision for the future and say what really needs to happen in the next 20 years and what is the aspirational vision we want to achieve. And I think that is a very important work of ICAO. And we are, again, supporting actively to identify the key enablers, the operational scenarios. So we, and it's something we organize, again, not only in Europe, but in last January, we organized a very interesting workshop with NASA in Silicon Valley, with all these, Silicon Valley companies, the Jobbies, the Archers, and they all have different business needs. But a common thing is that many of them, or most of them, they want to start operating in the next few years. And when we try to discuss with them, but what about the next steps? How to scale up operations? That is getting very fuzzy. It's not clear. So we believe more research is needed, more effort is done, and definitely we welcome the role of ICAO here to create a vision that, a global vision that we can all share. Again, collaboration is key. So with this in mind, just the key message is this. We are working on all these aspects, but at the end, we can only have one sky. So we definitely need this vision for an integrated traffic management. And that is our commitment, that yes, as we are working on all these transformations for ATM and make this pathway to advanced air mobility, at the end of the day, we need to make all these visions compatible and have an integrated airspace. So these are, well, some of the key messages I wanted to share with you. I'm happy now for a good discussion. Okay.
Thank you, Eduardo. So let's just step back because our next speaker is Pascal, and Pascal comes from Thales, and we've heard about the airborne side and the challenges there. We've heard the operations and what they would like to be able to do and need to do to meet customers. But now we'll hear about the ground system side, so the technology that's going to support those operations and do it in a connected way with the aircraft. We've got trajectory-based operations going on as well and new communications. So how are we going to connect all this stuff together? So I invite Pascal to come and talk to us about the perspective of the ground systems and their technology innovation. So thank you, Pascal.
Thank you. So I would just, it's next, something, no? Yeah, okay, sorry. I would just to go back in the past and the present day to try to explain you how we need to go to new technology or new kind of techniques that we can develop in air traffic control systems. In the past, in fact, we tried to deliver systems to allow the air traffic controllers and the ANSPs to do their job and control the aircraft in the skies. But finally, the technology evolved, and we were always trying to manage the obsolescence of the hardware, the obsolescence of the software, adding new, I would say, development for the the different regulation in different countries, etc. But since some years, and thanks to the collaboration we are doing with ANSPs, thanks to SESAR and other, I would say, projects in the world, we try to have, in fact, operational benefits more and more developed in the system by adding different techniques to help the controller to take decisions in his task of the day. It is the first steps, and we thought, in fact, that it's a good way to collaborate with the NSPs, and in fact to find the best way to make evolution in the different air traffic control systems. And this is what we are seeing now, more and more, and this is what we can see in the future, is that more collaboration, more open platform to develop the new concept, and try not to help the controller to take the decision, but help him to be more optimized, and in fact to improve the collaboration making and the decision making of the controller. So we call that sort of digital assistant, but finally this is what you already know, and we talk about that. This is artificial intelligence, could be machine learning. This kind of techniques can be used, in fact, to improve the decision of the controller, and not, in fact, to replace him for sure, but just to help him to be more optimized and to manage the traffic and continue his task in a better way. My last word will be the more important things is collaboration. So my colleagues already talk about that. The collaboration with the operational users, which is in fact the NSPs for us, is crucial, and R&D program like SESAR is helping us, in fact, to collaborate. And for sure, some colleagues talk about quantum computer. Yes, okay, why not tomorrow quantum computer to accelerate, in fact, and to have algorithms that are working better. But the main goal, it's not technologic, it's operational benefits for the operation, which is air traffic control. So thank you, I think.
Thank you, Pascal. So, let's just move this forward because I need to step forward to, right. So our final panelist, and it's last but not least, and especially not least because he's going to talk about safety. So all of this talk of all the technological change and everything else, we have to remember we're in the safety business. So Albert, I'd like to invite you to talk to us about the safety perspective in our changing world. You'd like to come and take the podium.
Thank you, and thanks for the invitation to talk about safety. I'd like to talk about safety. I show you a slide, and you probably think, well, we've seen that a million times before, but I'm showing this slide for a reason. This is a slide of comparison of safety of aviation with other modes of transport, in particular riding a motorcycle, which I like to do, and some of you might also like to do it, and that riding a motorcycle is very dangerous, you all know that. But so is aviation. Aviation is not inherently safe. Inherently, aviation is very risky because we fly at high speeds, at great altitudes, in a hostile environment, with large amounts of fuel on board. So inherently, there are many risks, but still we manage to make it a very safe mode of operation, and that is thanks to the tremendous effort of people like you. And we often tend to forget that this really takes a tremendous effort to be as safe as we are. And one of the things that we have done in the past is that we have made requirements for system safety. For instance, in CS 25-1309, there's this requirement of the failure probability of a safety critical system, which is 10 to the minus 9. And if you say it quickly, 10 to the minus 9, then yeah, you say, well, that's a number. But if you think about it, what it actually means to have a system with a failure probability of less than 10 to the minus 9, it means that if it runs continuously, you expect less than one failure in 114,000 years. Now, if we go back 114,000 years, that's at the beginning of the last glacial period. There weren't even, the Homo sapiens had not reached the part of Europe that we are in right now. So if you had the system sitting there, yeah, you needed to have a woolly mammoth to switch on the system. And then you have to wait until now, and then you expect less than one failure of that system. So that is incredibly safe. And it is incredibly difficult to design and manufacture systems that are so safe. But you can do that, and we can do that. It's even, I would say, even more difficult to demonstrate to the certifying authority that you have a system that is so safe. So the demonstration that you meet this objective is in itself a difficult effort. And we managed to do that for the systems that we have currently in place. We understand the hardware, and we understand the environment in which the hardware is operating. And we know the systems that we need to use to demonstrate the risk assessment methods that we use to demonstrate that we meet this target. And it's not by flight testing. You cannot demonstrate this by flight testing. The probabilities are so incredibly small that you need really good methods for risk assessment and to demonstrate it to the authorities. And now we are moving into another world where we have these connected systems. And in the past it was very much based on hardware, and we understand the hardware, and the risk assessment methods are used and usable for hardware. But now we are running into, we are developing into interconnected systems, software, artificial intelligence, and the methods that we use to demonstrate compliance are not sufficient. They do not work for software. They do not work for connected systems. System safety in itself, it's about systems. But if you have an Internet of Things, you don't have a system. Where does this system end? It's not ending. So we need to have different methods. At the same time, there are new companies coming into aviation, trying to develop products, which of course we wanted as a society as well, but they are not used to the aviation way of working. And you have small companies, which don't have experience maybe, but you also have large companies like Google and Apple, which have a strong push, but they do not understand aviation, and they do not understand how it works to certify a system and to demonstrate the 10⁻⁹ compliance. So that is really an issue. So, and I don't have answers. I only have questions. The question is, how can we support this innovation, but at the same time maintain the level of safety, the 10⁻⁹ that we are aiming for? So we need to have other ways of demonstrating compliance, taking into account the fact that we have different technology, connected systems, software, and artificial intelligence. And on top of that, we are losing the people that have the knowledge. And I'm afraid that we don't take in the younger people, the new talents, because aviation is not so sexy anymore. It used to be very sexy and used to be very, you wanted to work in aviation, but that's not the case anymore. So there are all those different complexities that make it very difficult to support this drive to innovation, but at the same time maintain safety in the way that we want to do it. And with that, I go back to you, Peter, and try to lead the discussion.
Okay, good. Thank you very much. So some thought-provoking words there. And before we move on, so I've got some here. I've got them here. Yep. Thank you. So we've seen a lot through the conference about the time date 2035, and you've heard some words around from our speakers today. And I tried to summarize some of this as we're going through the event as well. And these are the points that I got in terms of what are our challenges for 2035. So we've got integration, seamless integration, new airspace users, highly automated air vehicles, no pilot on board. Environmental responsibility, public support for clean, quiet skies, social license. Airports and vertiports, safe, efficient, all types of operation. Resilient point-to-point transport network for passengers and freight. Route optimization and prioritization. Airspace is dynamic, flexible, no segregation. Geographical borders, you don't notice them. ATM services are scalable. They'll meet the varying demands. Highly automated systems. Humans at this stage still in the loop, although there's some discussion about single pilot, automate, and then to automated operations for air vehicles. Exploitation of digital twin. New technology platforms that allow for ideas to operation to move more quickly. So they're more open to allow new ideas and change to be integrated. That services are more geographically independent, they're decentralized, they're virtualized, data's distributed, it's well organized, made visible using secure data flows and distribution. A dynamic list of ANSPs, and there are probably going to be more of them. We heard in one presentation yesterday about new ANSPs coming into the area. Not the traditional ANSP, but they're still providing a service, an air navigation service. So a more dynamic list of ANSPs. They need to be supported by a common data repository and a standardized exchange infrastructure. If you're going to allow people come in and out, you've got to have that harmonized data infrastructure, and it might be cloud-based, whatever, but it's got to be consistent. We just heard, it's got to be, we should be an attractive place with challenging jobs that we're attracting new talent and investment. And you start to read through some of the things that are facing us, it really should be. So let's start publicizing and attracting these challenges that we can engage people in. We'll need a framework of common standards and specifications that will facilitate safe interoperability and integration. Certification we talked about, regulating in uncertainty, application of AI, how do you certify it? You can't certify it certainly, but you need to certify it probably, maybe. Is it a risk-based approach? I don't know yet. But when you start looking at AI, which is generative rather than more traditional machine learning, you can't give a deterministic output. So how are we going to deal with that? But we're all saying we're going to be using AI in some way in that relatively near future. Security, the zero trust framework for cyber resilience and our safety leadership as a sector is sustained. We're still a safe organization. So there's some of the things I've captured. And I also like to go back to the verse beginning, the introduction. Klaus from Skyguide, he said about these 4 transition steps. And he had analog to digital, connectivity, data aggregation, and then algorithms and intelligence. And I just wonder from our panel, where do you think we are in that progress? So analog to digital, first of all, are we kind of, we're there, we're nearly there? Anyone like to offer an opinion?
Well, some things you can't make digital. You cannot have a digital engine. So there will always be analog systems involved. But of course, we are moving into a combination of analog and digital. Whereas I think most of the development is currently in digital. So I would say that, yeah, we will always be in a combination.
Okay.
I would add, I would look in particular at the ATM. I mean, today I think it's mainly analog, because the other day I was in Bordeaux at the Air Traffic Center, and I'm seeing, I mean, how many aircraft were actually using CPDLC? I mean, just a few. So meaning that today we are still analog in terms of the air traffic control. So I think we need to have a way to push that. So making sure that we go more to digital operations. Because I mean, when you look at how much, I mean, the analog, the voice in particular of the air traffic control can be prone to errors, I mean, that's something, I mean, we need to look at. That's a given. So I think we are not there yet. So we have the technologies, but sometimes, I mean, we have some adoptions issues.
From my side, as I has mentioned, I mean, this is the fundamental transformation that will be the main enabler for what is coming, and we are not there yet. I think we all agree that a lot has to be done. The industry is working on it. I don't know, Thales.
Okay. Now, I will come back to what has been done, has been said yesterday. What is digital? Because if you compare analog to digital, we are doing digital since 30 years ago, because we are doing software programming, so it's the same, it's digital. But digital, as we understand it today, it's digital, connected, and everything related and collaborative. So I think we are on the path, but it's not finished. And as you said, we know that there is some areas that are still relying on the, I would say, old technologies that are maybe not digital yet, and we have to deal with that. But yes, so I think it's adding more and more, I would say, advanced technology inside the systems we are providing will continue to be more and more digital. But I will remind what has been done yesterday, which is not only digital, connected and everything with the data and everything.
Yeah, I think we can work the other way back, because the next one was connectivity, and you raised that one, and so we're digitizing things where we need them to enable connectivity. I think that's an important message. So I think we can say yes, we're in progress. Priority is to enable those digital services which enable connectivity, because connectivity is the key to opening up a better operation. So if we say connectivity, if I work back around the panel, where are you with connectivity? Are we there yet? We had a panel in the very early first day talking about connectivity. So are we there? Have we got a good plan? Is it going to work? 2035 done?
No, I think it's starting. It's starting. We have some features and some systems that are connected together, but it's just the beginning. And
yeah, I think we'll.
No, it's okay.
So I think we actually, if you look at the ATM master plan, I mean, that is being set up right now. I mean, I think there's a plan. So if you look, for example, so I think you discussed that yesterday about ATN IPS, I mean, coming. So ATN B2, I mean, 2042, I mean, EPP, that is end of 2027. So meaning that, yeah, there is a plan. Afterwards, I mean, not there yet. So as I mentioned, security is not there yet. So because the current system is really unsecure. So, but yes, we have a plan, and I mean, we are working on the technology. So there is many projects, like for example, FCDI, part of SESAR GU, that is really supportive. So, I mean, we are investing a lot, and we are having many, many things ongoing today.
Connectivity?
Yeah, of course, we see more and more connectivity, but we also see a number of disconnects. Civil and military aviation, there are a lot of disconnects. commercial aviation and recreational aviation. There are a lot of disconnects. It's easy to say connectivity, but what does it really mean? And what do we need to connect in order to say, well, we have now connectivity across aviation?
Mm-hmm. So,
and maybe
connectivity for purpose.
One key issue that we have been discussing the last days, connectivity is one of the key priorities for the ICAO Navigation Conference. It's taking place now in summer. And the ICAO Secretariat, they have put forward a paper on connectivity, and it has been very interesting, the reaction from the whole industry saying we need a common understanding, because what ICAO is putting forward, we don't share it completely. So it means that, more research is definitely needed.
Yeah. Quickly moving on to
for sure. Afterwards, I mean, just resonate to the fact that at the end of the day, I mean, if we really want to operate efficiently, we need to look at that really from a global angle. So up to now, I mean, really the air traffic management was really regional, and I think now we need to make that also global. So that's something that is quite important. So that means interconnecting everything. So meaning that swim technology is very important. So in the end, I mean, you want to know, for example, the aircraft leaving from JFK that will be landing in, for example, in Zurich, you want to know when it starts. Because today the problem is that you will discover that too late. Yeah. So meaning that to be able to manage all of that, we need also the connectivity at really the ANSP level. And for that, I mean, technology like SWIM, that will be very important.
Yeah, I mean, you link quite nicely there for me to the data aggregation point, because it sounds so simple. Of course, we've got data and we aggregate it. Yeah, what else do we do with it? How many times?
You have so many actors, and you have the problem also of the data ownership. Data ownership is always an issue because everybody will claim, this is my data. And at the end, of course, you have the problem of security. Because whenever you connect something, I mean, you have the risk. And that comes afterwards. So what's going to be the impact in terms of, let's say, in terms of security, in terms of safety? Because security and safety, they work together. And I think that comes back to your discussion, I mean, around, I mean, what is the probability of having a problem at the end?
I think there's also another important point on this data aggregation. If we don't think about how we structure the data, how we have a common understanding for what each piece of data means, not just what it's called, what it means and how you can use it, then when you go to step 4, algorithms and intelligence, it's not going to work.
Yeah,
I mean, interoperability today is difficult because we have these different definitions in different places, not just in Europe, around the world. We call the same thing. Well, the same name is describing something that's actually a bit different.
Yeah, this is why the development, for example, of FFI's Release 2 is so important. I mean, just to make sure that we have a standard everywhere. Because, I mean, right now, I mean, we are more, I mean, pre-flight, and R2 we go during the flight, so meaning that for sure, I mean, you don't want to have any mistakes.
Yeah, so I think, does anyone else want to add to this data aggregation point? I think there's a warning here that we could really miss something important, that if we're progressing through these 4 stages, we won't be able to exploit in a good way the algorithm's intelligence if we don't have our data stored, characterized in a consistent and unambiguous way.
Yeah, and I want to add that the way you aggregate the data is depending on the purpose, the objective of the data aggregation. I think it's different for efficiency purposes than for certification purposes, where you also want to have data aggregation. So that needs to be kept in mind. What is the purpose of the whole exercise?
So I'll quickly do, as we're coming out of time now, so I'll take one question from the Slido, which is something we haven't covered, but how and when do we envisage automation reducing the need for humans in the loop, both in the cockpit and in the control facility? So anyone want to take that?
Well, we've been doing that for many years.
Yes.
So how and when? It's right now, and it is continuing.
The goal is not to remove the human in the loop, to keep it, but to ease his work and to give him or her, depend, we don't care, the good tools, in fact, to take the correct decision. So I'm talking for the ground system, but I imagine it's the same for the pilots. And let the urban side.
I think at the end also, what is important is what for. And the question is mainly, I mean, this should be for efficiency, for example. Efficiency, safety. So if you look, for example, EPP, I mean, of course, there will be some interest around safety because, I mean, you know in advance, I mean, what's going to be the trajectory of the aircraft so you can predict that much better. So meaning that automation, I mean, for what? I mean, the question is, I mean, when do we remove the pilots? For sure, I mean, many people, they are saying, okay, many of the problems I mean, are coming from the pilots, but sometimes also they're able to save lives. So it's always a complex debate.
Yeah. Okay, so I hope we've answered that one in a good way. And just really starting to wrap up, I took a quick look at the poll that's still running in the Slido, deliberately, just to see how this question about what do you think, what comes to mind when you think of airports in 2050? You know, what's your thoughts? And I took a snapshot of it lunchtime. I don't think it's changed very much now, but we had new aircraft. Okay, we talked about that. Technology, talked about that. Connectivity, we talked about that. Clean, and other words around clean. Safe. So the same sort of themes are coming up, no matter whether we're talking about airports, which we're not represented here, but it's just interesting to have that additional dimension of airports. And then one last thing from me, we promised that we'd also take a sort of a bit longer look. So we're more looking at 2035, and we heard some words that were maybe a bit longer term, but if I take a quick look at beyond 2035, what might we be looking at as our next technological frontier? Because it will move on. So are we looking at swarm vehicles, uncrewed, hyperconnected vehicles, autonomously negotiating with each other as a swarm? Connectivity, which is now zero latency. Just imagine what you can do with that. We talked about quantum computing, but using it for not just our own security, but information processing and establishing a digital trust. Real-time linguistic translation. Could be interesting, given how many world languages we have. Is there a role for real-time linguistic translation? Blockchain. There was a question in the Slido about blockchain. And I'm not going to go into the detail of it now. It may not be blockchain that we use, but being able to ensure that the data integrity is there and that we're consistently updating it and then exposing it for every other operator. Internet of Things, embedded sensor networks, we had heard about that. Immersive reality, virtual and augmented, the digital twin, maybe that's nearer time, but digital twin for use in real-time scenario optimization, artificial intelligence, and I mean generative, not lesser forms of AI, smart living materials, healing networks. So that's safety question. Can we have the system that heals itself? Natural language processing. So we can create things using our own language. And different new forms of computing, from neuron chips, that just extend the AI thought. You know, can you do the direct processing? And Eduardo, thank you very much. I know you have to leave now. I'm just wrapping up. So I'll leave you with those thoughts. Those are things that we're going to be talking about in a future symposium. Maybe, maybe not, but let's not ignore them. They could be useful, they could be threatening, they could be beneficial. Unless we look at them, we will never know. Thank you very much, and thank you to my panelists. And Eduardo, have a good trip back.
Thanks.
Thank you. Thank you.
Thank you. Okay, now I would like to introduce our last flash talk. In today's fast-paced, technology-driven aviation industry, promoting diversity, equity, and inclusion It is not just a matter of social responsibility, but it is an essential thing for the industry's growth, innovation, and sustainability. In this flash talk, we will explore the critical need for the aviation sector to attract top talent facing industry skill shortages that we have heard in previous discussions before, and also to attract diverse backgrounds and create an inclusive environment where innovation can thrive. This session will focus on ways to foster DEE in aviation and empower individuals to address environmental concerns and navigate complex airspace challenges. I would like to introduce to you Marita Linden. Sorry. Ms. Linden has been engaged for many years in pro bono activities to accelerate equality, diversity, and inclusion in transport and to promote female talents in the aviation and space industry. This motivation is driving her engagement in IAWA, International Aviation Women Association, where she is an active participant from 2020 as a member of the board and Vice President Europe Africa, and since January 2024, President-elect and acting Vice President Asia. She was honored by the European Union Commissioner for Transport as an early EU Diversity Ambassador in September 2019, and is a member of the EU Platform for Change Women in Transport. It is a pleasure to me to introduce you to Marita Linden. Thank you. The floor is yours.
Thank you very much for having me, and I hope you have the time now, and I see there are quite some people still here. This is really a pleasure. One word to IAWA, that's an organization which has been founded 36 years ago in the US from a group of women who found themselves always very lonely as the only or maybe two women in the room, and then I thought we need globally connect, and now it's a global network of women in leadership in the industry. And to say it's not, we don't do that professionally, so everybody works there pro bono and is just engaged to foster this leadership. I would like to catch up from yesterday morning. We have a dream. We have the dream to have a safe, secure, resilient, sustainable, and efficient ecosystem, aviation, traffic management. But all is nothing when we don't have the people who manage it, who operate it today, and to innovate and bring all the ideas, also in particular also from the last panel, into reality in the future. Oops. So, and actually the introduction for my speech has been very much done by Christine this morning, because she was pointing out about the challenges when we haven't enough staff. And when I was preparing for this speech, I looked, okay, maybe some statistics about shortage of staff, and at the end I found it's much more compelling. And you see here just the sublines, it's in all the media, and it's throughout the globe. And you have about the staff, shortage of staff of EDCOs, and we heard it also now, of course, the human in the loop won't go away in foreseeable future. It's the same with pilots and of practically every part of our value chain, where I will come later to it. And whatever AI and automation will bring, and it was here by the last speaker well said, it makes it easier to compile data, etc. We will still need the people, the human in the loop. I would like to quote the new DG of the European Commission, Marta Kopczynska, who wrote recently, "We need the very best minds." And I think this is a great quote. And why I'm showing you this whole topic is global, and I brought just to see. This picture, what I scanned here, is from a newspaper in Australia. I'm not saying that we need to do newspaper ads, it's something for the marketing people, but what is interesting here is you see a woman, and in Australia, it's from Western Australia, they are very strong in mining. And they advertise here for women in the industry, and they advertise with the positive elements. They say, we need resources, we need metals, and all these things with this bad image of mining, many of you may have heard, and it's a big discussion, but reframe it and say, when you want to be part of the green transformation, we need the best minds in this industry. And also this woman there is on safety and human factors, so it's not necessarily only on the engineer field. So it's very clear about these the very best minds. We are in a global competition. The growth in Asia will absorb also lots of minds, lots of human talents. So it's not a strategy anymore, okay, if we don't have enough people here, we just grab them from anywhere else. Because it's a global topic and everybody has the same challenge, is working on the same attempts. And also even here, EUROCAE, of course, is very much domination of engineers. I'm an economist, so apologies for that. We need engineers, we need the people in STEM, but we need the ATCOs and we need the pilots, but we also need good lawyers, we need the human factors people, we need the good project managers, we need everybody. And in our industry, we have a place for everybody who is engaged and want to work. And so we can really embrace every of the good minds. This picture here is from a young woman, and you see on the right hand, it's about a car. A group of students first they designed it aerodynamically, the best shape, and then it's a solar race in Australia. And this young woman is Nadine Dursma, and she's a scholar of Iowa, so know her personally. But why do I show this picture? Not only that she has a double master in robotics and space engineering, she is in this challenge about the solar mobile engaged, but I want to share a short story with you. When she started this group to develop the solar mobile, they had, of course, to do all these calculation, mathematical things to make the best shape or develop the best shape for this solar car. And they all were doing this calculation, and she said the boys then came to her, the male companion students, and checked her calculations, because they didn't trust her. They didn't do that with the other male colleagues, they just did it with her. How would you all have felt early in your career, when you are the only one who would have been challenged just because of your gender? I mean, later they learned she's an extremely smart mind, maybe one of the smartest minds in this generation I know, and that they came to her to help, that she helps them to solve some mathematical problems. But just to share this story with you, that we have to change sometimes our bias and our mindset. It was said earlier, it's to attract the talents and then to retain. And I could now show you 30 minutes of different papers where it's all proven and what we can do. Of course, not only because of the time, I won't do that. There's lots of material. The European Commission has something what's called the Platform for Change. There's even in 27 language materials to go to schools and a lot of studies on best practices in companies. The IATA has a program, 25 by 25, lots of materials. CANSO has developed things. Christine Berg, she mentioned the Year of the Skills. So we have material enough. So to get inspired, to get ideas how to do that, there's a lot out there on the market. And that's the same with here, diversity and inclusion. Without diversity and inclusion and having the best minds, independent of the color of the face, of the gender, etc., we as aviation will miss out because of this global competition, and we must all really get aware about that. And I could as well now show you lots of statistics from McKinsey and all the consultancies why diversity promotes innovation, why it brings better financial performance. Well, I think that's not the case, and of course I don't do that now. But I want you to take 3 takeaways from this flash talk and give it some thought when you go home, what each of you can do. So first, that we understand that diversity and inclusion is a success tool for innovation and sustainability. So we really need it, and it's not something which we delegate or think it's done by HR, and nobody of us has something to do with that. We need to understand and embrace that and really see that we all have a responsibility doing that and that it's good for our industry. Recently, even the chairman of JP Morgan, of this big investment bank, was bringing this topic up in his big shareholder letter, and also mentioning some people are a little bit annoyed with this, oh no, don't come again with this diversity and inclusion. And people who are honest come to me as well, oh, Marita, I cannot hear it anymore. Because it was very much brought into attention, or we have more important problems. No, yes, we have lots of important challenges, but for our industry, inclusion and diversity and embracing all talents to have the very best minds is as well a very important challenge. The second thing is be a sponsor and encourage. I guess most of us had some people when we were young in our jobs who supported us. And that's not necessarily the formal mentoring, also rather newer term, maybe in some of the business life we all had. So I'm turning now, or it's the 35th year now in the industry. So you can support others and watch out. We must not only support the ones who look like the younger selves of ourselves. Just watch out that other people who look a bit different, who are different, that we promote them, that we don't overlook them because they are shy. They may have great ideas. Be a bit more open. I think the society, the next generation, is more diverse, and we need to look for that, and that's a responsibility everybody of you, everybody of us has. So, and that we cannot delegate to HR. That also makes your team better. And to promote that, we have here these wonderful working groups with about 5,000 people engaged. And we know when you're young, it's good to send in projects, to be out in the live world, in the big wilderness of the industry. Send your younger people there. Let them experience that, the greatness of EUROCAE, of other things. Let them connect and get them challenged. The majority will grow to the benefit of your company and also of the whole industry. And that's a task for each of you, and not to be delegated neither. Who knows what a manual is? Honest. Who has heard the term before? Okay. Manual is the term, it means all male panels. It's a term not invented by me, many, many years ago, and I Googled again, nobody knows where it comes from, the term, and somebody invented the term because it's an imminent thing, and it's not a term for aviation. It's a general thing because it happens very, very often, and you mustn't look, if you know these guys, on purpose. I could have lots of pictures of our industry there randomly from the internet, and purposely not from aviation. Because my point is not to blame anybody, and I know how hard it is sometimes to find different speakers. And it's not as well to replace old white men by old white women. And I can say that because I have a good hairdresser. No, we need diverse panels, and we look for different people from different backgrounds, and when we really search, we find them. And it's also a chance for other people, for younger people, for diverse people, whatever, and I'm on purpose a little bit general with the word diverse, to then learn and be on a panel and sit there and get challenged, but also to grow. So please remind this word manual, and there are people, and for example, I think the CEO of LVNL is one of them. When they're invited to a panel, they ask who are the other panelists. And when it's not a diverse panel, they say, sorry, I don't join. Give me a diverse panel and then I'm coming. So each of you can change something. And I think each of you knows also lots of great women, and we had really these 2 days, thank you, Anna, a lot of great women here also on the panels in the flash talks. So they are out there, and there are other people as well, globally, of course, as well. And so they are there, so please be a positive role model and promote these different, these various panels. with this, I close. That's the past president. And the motto of Iowa is Connect, Inspire, Lead. So I invite you, be inspired a bit, inspire other, because from Alfred voice, our industry is sexy, or should be sexy again. I don't know if sexy is the right word. It might be also very discriminative again. We say it's attractive with your inspiration, and go out there, make it diverse, get the people. We need the very best minds. We can do it because we're a great industry. We connect people, giving the word connectivity a little bit different twist. Young people want to be part of this positive transformation into green. Our industry is maybe in the greatest transformation ever with being green, net zero. We all can contribute and invite you. Please do your part because it's our great aviation industry which will benefit. Thank you very much.
Yes, thank you, Marita, indeed. Thank you very much. Definitely, gender equity is important for EUROCAE, and our association is pretty good on that aspect with a perfectly balanced staff led by a woman. It's not so that often that we can say that in our industry, so let's be proud of that. Diversity and inclusivity are also important matters that are part of EUROCAE's DNA, and it shows in our working group. We are approaching the end of the symposium, but first I would like to thank the members of EUROCAE and the newly elected council that have renewed their trust and elected me as president for another year. So I am very honored and happy to be given the opportunity to continue serving the association for this other year. Back to symposium. Thank you. Back to symposium, I won't even try to summarize every panel, every working group. It was very rich, very interesting, and I must say that I have learned a lot this year again. I will just maybe recall a few details. First, I was very pleased that Francine recalled you about Martin Luther King quote, "I have a dream," and thank you for quoting that again at the end of the symposium. It's good to have a dream, but what I also want to keep in mind is that it shows us as aviation is changing, as we are mobilizing all our strengths and energy to make change, innovation in aviation, the society also, on their side, is changing. Lots of things are happening, and we must keep that in mind. We must be aware of all that is happening outside of our industry, and take that into account in our decision and our mindset. As I said, I won't go much into detail, just to say that I was very impressed by the one slide that could summarize the global connectivity, hyperconnectivity in 10 minutes. So thank you very much for that. I also would like to thank you for this mammoth picture, because now I know how I can explain to someone that is not an engineer what is 1 out of a billion in a simple way. So thank you for that. And thank you to all the panelists and to all the people that were here to make this symposium very nice. And I won't take any more time, and I will give the floor to Anna for other things.
Thanks, Guillaume. And I think this slide says it all, right? Thank you to all of you. Thanks to all of the panelists. I won't even go into detail. Thanks to all the speakers. Thanks to all of the sponsors. Skyguide is our platinum sponsor, and also lots of support here for the logistics and the organization. Our gold sponsors, Airbus, Indra, and Thales. Silver sponsor, Collins. Frequentis as bronze sponsor, and for our nice lanyards, Honeywell and Anzen, and our partner, the European Commission. So thanks to all of you. A big round of applause to all of you. In a few days, you will all receive an email with a post-event survey, so please do help us make this event even better, because we do have a future edition of it, and Guillaume will not spoiler it this time, but he will let you know where it will take place. You will also receive in that email a link to the videos, because the event has been recorded, and all of the presentations and panels will be made available on our YouTube channel. Along with the pictures, Denis has been jumping around here and making us all laugh, and I'm sure he will make us all look very nice on all the pictures he's taken. But last but not least, I would like to thank my team who've made this a very enjoyable event. So thank you to all of you who've made it a very enjoyable event, and I turn it back to Guillaume.
So the last person we need to thank and applause is Anna, because really thank you very much for all you did. So now we are really reaching the end. So the question at the end of a meeting is when do we meet next and where? So there is a video that will tell us where we are going to meet next year for the symposium. So I won't spoil anything and that won't reveal. Just watch. So now we have really reached the end. So for sure, our Council and Technical Advisory Committee will take all the information we have discussed during these two passionate and very busy days to align EUROCAE strategy and to identify the potential standardization activities stemming from this discussion. So now it's time to say goodbye and farewell. Have a nice stream back and meet you all in Madrid next year. Goodbye.